So this is about as difficult as these cross-section problems get. So this is going to be quite a fun example for all of us to go through. So the base of the solid S is the region bounded by the ellipse. 4x squared plus 9y squared equals 36. Now the cross-sections perpendicular to the y-axis are isosceles right triangles. So that's the big part there, isosceles right triangle. So remember, an isosceles triangle means that it has two sides that are congruent. And since this is a right triangle, this one has a hypotenuse, and this is actually a very special case of a 45, 45, 90 triangle. If you guys remember last year going over 45, 45, 90 and 30, 60, 90. 45, 45, 90 though had a special formula. If this is A, then this is A, and this would be A square root of 2. So basically, if I were to give you the hypotenuse, like let's say the hypotenuse was 10, in order to work backwards, this would be 10 divided by the square root of 2, because in order to go from here to here, you would multiply by the square root of 2 to get 10. So remember, if you're given the hypotenuse, divide by the square root of 2 to go backwards. That's really the hardest part of this problem, and you'll see where this comes in later on. So the hypotenuse is lying at the base. So we have a triangle, isosceles right triangle to be exact, and it's perpendicular to the y-axis. Its hypotenuse is laying at the base. So what that means, and even though this is not drawn to scale, what this means, this is a right triangle. This is the hypotenuse right here. And it's based upon this function 4x squared plus 9y squared equals 36. So our integral, we're using the y values. That's fortunate that at least we have that. We're going from -2 to +2. And it's in respect to the y-axis. So let's go ahead and figure out what's going on with our triangle over here and how we're going to find the area of a triangle. So I'm going to keep that up because it is an isosceles right triangle just like we have here. We know these are 45-degree angles. These are both the same side measure. So what in the world is this length? Well, we know that our x, let's just go ahead and solve for x. 4x squared plus 9y squared equals 36. So we'll have 4x squared equals 36 minus 9y squared. Divide by 4, so x squared equals 9 minus 9 over 4 y squared. And so x equals plus or minus the square root of 9 minus 9 over 4 y squared. So remember, the positive one is, since we're talking about x, is this part, and the negative one is this half. So our formula is only giving us half of it. It's only giving us, because it's split into two, a positive half and a negative half. So 1/2 of this is going to be the square root of 9 minus 9 over 4 y squared. So that's just the right half. So to figure out what our total hypotenuse is, it's going to be double that. Now let's figure out, how are we going to figure out the area of this triangle first? So we know that this value is the x. It's actually 2 times x. So how do we go backwards? Well, if you remember, the area of a triangle is base times height, but they have to be perpendicular to each other. So we really need these two sides. So how do we go backwards? Well, remember, we divide by the square root of 2. And this one over here would be the same thing. So our area of this triangle is going to be 1/2 base times height. And so that's going to be 4x squared over 4. So in other words, x squared. So I just put in that 2x just to show you that we're doubling. Whatever this is x. We're doubling it. So I already took that into account. So our integral is really going to be x squared, where x is this function here. So we're going to go ahead and integrate from -2 to 2. And it's going to be x squared. So it's going to be that square root of 9 minus 9 over 4 y squared squared dy. Now that gets rid of the square root. So we're going from -2 to 2 of 9 minus 9 over 4 y squared in respect to y. So from there, you just finish it out, integrate it, and evaluate the rest of it. But hopefully that explains what's going on there. Like I said, this is probably one of the most difficult things that you'll see in cross sections.